Okay, phew, easy one after that difficult one. Alright, find the x-y-intercept. Hey, this is the easy one I was telling you about. No fractions. Alright. So again, going what we did before, if I'm trying to find the x-intercept, that's where I let y is 0. And I just plug this in, so I get 7x plus 8 times 0 equals 56. 8 times 0 is 0, so 7x is equal to 56. Well, 7 goes into 56 8 times. So notice how it's the opposite. So 8, 0. And again, it's because 7 times 8, like I said, is 56. So guess what the y is? We already know. So the y-intercept, where I let x be 0, let's see if you know. No, so we're going to do it. 0 plus 8y equals 56. Okay, that becomes 0. 8y equals 56. Divide by 8. Y is equal to 7. So hopefully your teacher gives you an easy one like this problem. Your teacher asks you to graph, you just plot those points on the graph and connect the dots. That's all you gotta do. Alright, graph the line containing this. So if I had to graph that, I would graph those dots, which I'm about to do here. Connect it. It says find the slope. Now I can find the slope using the formula. I can do it using the graph section. Okay? So let's go ahead and plot these points. -2, 1, which is right here, and 7, 1, -3, down here. So I connect my dots. As best as I can. So, how do I find out the slope? Well, again, we're going left to right here. Started here, and it went down and over how many? So how many down did this go? We'll count. 1, 2, 3, 4. So it went down 4. Well, if it's going down, we're talking about slope, it's negative. How many over did it go? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Guess what your slope is? -4/9. Can I reduce that fraction? Absolutely not. So that's my answer. Let's say I didn't know. I don't like this. What are you doing? It's freaking me out. Go to your trusty formula, and we're going to get the exact same thing. Watch. So if I make this x1, y1, and this x2, y2, okay, I'm going to get -3 minus 1 over 7 minus -2. -3 minus 1 is -4. 7 minus -2 is 9. Same exact answer. It's up to you which one you prefer. Your teacher's not going to care. You can do it based on the graph. Do it. If you need to use a formula, use it. It's whatever's most convenient for you. Oops. Sorry about that. Technical difficulty. That was from earlier. Solve the following system of equations. This is an equation. Now here it doesn't say to use substitution or elimination. Your teachers have shown you both. As far as I know, they might tell you which one to use on the test. They might not. So I'm gonna show you one where it's easier to do substitution, like in this problem, and later on it's easier to do elimination in this other problem. So I just want you to see both, so you know how to do them, okay? And it's up to you which one you prefer. I'm not saying one's better than the other. In this case, it's kind of set up to do substitution because it's white. I'm just pointing that out there, okay? After we're done with that, we need to figure out if it's consistent, inconsistent, or dependent. So here, anywhere I see this y, I'm going to plug in 4x plus 12. If I do this correctly, I should only have x's, no y. If you still have two variables here, whoops, if I still have two variables here, I did something wrong. Okay, I shouldn't have x and y. So from here, I'm going to work this out, try to solve for x. So I multiply 2 and I get 8x plus 24. Look at this, I get the same thing. Now, some students can stop right here and see that guess what? This and this are 100% the same. If one of them was a minus, they're not the same. And know that if they are the same, it's dependent. I can stop right here and write this and be done, and I should be able to get full credit. If you don't know, you can't solve this. Your next step would be to subtract your x's or your numbers. Watch what happens. So let's say I don't know. Continue on the problem. Okay, minus 8x. Boop, boop. Uh-oh. They cancel. So I get 24 is equal to 24. Maybe now you see it's dependent. That's another way to get the same thing on either side. Let's say you still don't. You go minus 24, and you get 0 equals 0. That's another way All signs point to dependent, okay? You get the same thing at any point on both sides of the equation. So 8x plus 24 equals 8x plus 24, dependent. 24 equals 24, dependent. 8x equals 8x, dependent. 0 equals 0, dependent, okay? So if they're the same, that's dependent, alright? Either one of those, any time, you could have stopped and said dependent and got full credit, in my opinion. Alright, so next one. Ooh, so here we're going to graph, okay? Then we're going to figure out if this is consistent, inconsistent, or dependent. So we're going to graph and slope intercept like we did earlier. This is in red, okay? I start with 6, my y-intercept. I put a dot there. Now my slope is 4 over 1, correct? So I go up 4 and over 1. So count up 4, go over 1. That's my line. Draw, connect the dots. Okay, let's do the other one in a different color. Let's use green. So here, I again started with 6. Well, that's the same formula. My slope is 2 over 1. So I go up 2 and over 1. It's not going to be the same graph. 2 and over 1, about there. So this one looks more like this, okay? Now, because they intersect, if you have two lines that intersect at a point, that point is your solution. So in this case, it is consistent, and your point 0, 6, that's this point right here, 0, 6, where they intersect, and they don't intersect again. I know it looks like they're intersecting here, but they're not. Don't pay no line to that, okay? This is your answer. So this is a consistent system of equations, okay? We could have solved this with elimination or substitution as well, but this was just easier, and this problem they want us to graph. So this next one does determine if the given order pairs a solution, okay? Well, to figure this out, we're going to plug them in. If I plug them in, I need to get the same thing on one side that I get on the other. If it is a consistent, if it is a solution, okay? If I don't, and you got to test both of them, because I've seen cases where it works for the first one, but not the second one. And a lot of students get lazy, do the first one, go, oh, okay, move on. And then they get it wrong. They go, well, I was right. Now the second one. So plug them in for both. Or as long as you do the first one and it's wrong, it doesn't work, then you know you can move on. It's not a solution. So here I'm going to have 6 times 4. I'm just plugging in those numbers for x and y right here. Plus 3 times negative 1 minus 7 equals 0. Well, I get 24 minus 3 minus 7. That's never going to give me 0. Nope. I'm going to get 21 minus 7. I'm going to get 14. That does not equal 0. Okay, so nope. Let's try the next one. A little bit. And do the same thing. So start again, and I'm going to have 6 times 3 over 2 plus 3 times 0 minus 7. Does that equal 0? Okay. 6 times 3 over 2 is going to give me 18 over 2, which is going to be 9. You just calculate if you're not trying to get that. This is 0, so I get 9 minus 7 equals 0. Well, that's 2, and 2 does not equal 0. So no, neither of them are solutions. So if I did get a correct solution, I get 0 equals 0, or same thing on both sides, okay? So make sure you test both equations whenever you do this on the exam. Now, next one is also asked us to graph and figure out if it's consistent, inconsistent, or dependent. Guess what? It's inconsistent. How do I know this? I have not graphed anything. I am looking at this problem. It's not because I've already done this for you, for students. It's because of the equation. What do they have in common? The same slope, negative 2x. What's different? These numbers. If that's the case, it's always inconsistent. Why? These are parallel lines. Remember we talked earlier about the same slope equal parallel lines. Do they meet? No. Okay? Dependent systems are the same line, one line. It's one of the lines that's in disguise as the other one, as we saw in that earlier problem, where you get 0, 0. So let's go ahead and graph them. Let's look at the graph. Alright, so I got this first one, y equals negative 2x plus 8, if I do it in green. Start at 8. Right here, put my dot. Go down 2 over 1. This line. Okay. Now, I unfortunately did not get a nice one here for the second one, where 13 is on this graph, negative 13. So I can do this kind of like as a ballpark, or I can just go ahead and plug in a number and show you what it looks like. Okay, so from here, I just went ahead and just figured it out by plugging in a point. I picked negative 3, and so I did negative 2 times negative 3 minus 13, and this gives me positive 6 minus 13, which would give me negative 7. So this is a point negative 3 comma negative 7, which I plotted on the graph, and that means my slope to go down to and over 1 to find the next point. So if I go ahead and graph this, notice these are parallel, so they're inconsistent. Obviously parallel, they're never going to cross. They don't even look like they will. So inconsistent, there's no solution here for like a number to put in because it's inconsistent. Okay. Now this one, as far as I understand, most of you have not seen this where you had to multiply both to get an answer. You're probably like, what is she talking about? So what I'm going to do is kind of cross this out, okay? Don't pay attention to that. Well, you know, I'm going to need it, okay? Where I'm going to have to take this first one. I'm going to multiply it by a number. We're going to see what happens. So in this case, I would multiply this second one by 2. So just listen to me when I talk about this. And then this would be 10 and 1. Okay, so this is mine. This is my thing. So forget about this one that was over here. Okay, this is where I'm starting now. Now I need to get them to be the same. So this is one where I'm going to use elimination. So to get them to be the same, I need to get the numbers, either the x's or the y's to be the same. Well, okay, so I need to get 10, so I need to multiply by negative 5. Because I want to get 1 plus, 1 minus. Multiply that by negative 5, bring it on down. So I get 20x minus 10y equals positive 60. Well, hang on a minute, they're the same thing, except they're opposite. Sorry about that. So whenever I go to add these, I will get something that's not gonna, we'll see what happens. So here, negative 20 and positive 20 give me 0, 0, 0. Uh-oh, 0 equals 0. We said earlier that this was an example of dependent. So this is a dependent system. Because I get okay. Alright, very last problem here. It says find the slope of a line that passes through these points. Find the line that passes through these points. Are these parallel, perpendicular, or neither? Well, let's do it. Let's do the slope formula. Okay, x1, y1, x2, y2, x1, y1, x2, y2, whoops, y2. So here, my first one, I'm going to have negative 2 minus 5 over 9 minus 0. It's going to give me negative 7 over 9. Can't reduce that. Second one, I'm going to have 2 minus 6, or negative 8 minus negative 3. 2 minus 6 is going to give me negative 4. This is going to become plus in the middle, and that's going to give me a negative 5. Well, negative over negative is going to become a positive, but again, look at these two. 4/5, negative 7 over 9. They're not the same. They're not opposite reciprocals, so this is a case of neither. Okay, so I wish you good luck on your exam. Hopefully you will do well. Please write down stuff so you can get partial credit. Show all your work, especially if you're using a calculator. Double check things like this. You don't make little mistakes like forgetting to take out that negative there, making that positive. Just be careful, take your time, go through and do this so that you do your best on your exam. Alright, good luck. Bye-bye.